Hello, everyone, my students and my colleagues out there. I'm Victor Odigomao here. Once again, we're here to look at a problem that has to do with the sum of a geometric progression. Remember, in the last class, either sequence 18, we have been able to derive the mathematical expression for calculating the sum of a geometric sequence. Right now, we want to see how we can apply that formula to calculate this question that is on the board. I got it from Waec question 1998, question 6. So the question says quickly, the third term of a geometric progression is 360, the third term. And the sixth term is 1215, that is 1315. You say find the common ratio, the first term, and some of the first four terms. So this is what we are going to do right away as quickly as possible. So here we go, solution. Okay. Now they gave us, I did this type of problem, if you remember, when I was solving examples in geometric progression. I've done this type of problem where you don't know the first term, you don't know the common ratio. So which place is going to be your access point? Like I keep on saying that in every mathematical problem, you try to look for the access point. Access point is the point through which you can be able to access that problem and start resolving it. All right. If I look here, I'm seeing the third term, and that third term's value is made available. So I can say from the mathematical expression, which says Tn is equals to a r raised power n minus 1, it then means I will start with T3. T3 is a r raised to power 3 minus 1. Okay, this is comma. I've written this, I say comma. So T3 is this, and this T3 is given to us as 360 equals to a r raised power 2. So I can write it as an equation that a r raised power 2 is equals to 360. So let me write this thing in so that I don't want you to struggle to see what I'm writing here. AR squared is equals to 360, equation 1. So I will again go back to generate an equation for this sixth one. So I will say T6 also, T6 is from the same mathematical expression, a r raised power 6 minus 1. Okay, 6 minus 1. Let me remove this. You've seen that it's a Waec example question. You can go and check it out. Okay, so 6 minus 1. All right, so the figure there provided is 1215 is equals to a r raised power 5. So I can write it as a r raised power 5 is equals to 1215. I call it equation 2. Now, like I was saying, that because this has power that is greater than 2, okay, these equations, we cannot solve this thing like simultaneous equation when we are looking at a typical example like this in arithmetic progression. So this one have degree 5 and this one have degree 2. The only way to bring this thing down is to reduce this power. That's the only access point. So I can say divide the higher power by the lower power. Divide equation 2 by 1. Divide equation 2 by 1. Let me do it where it will be very clear. I don't want you to, I'm sure you are seeing what I am doing here. Divide equation 2 by 1. Can I do it under here? Don't worry, let me do it over here. So we will have a r raised power 5 equals to 1215 all over, divide equation 2 by 1, okay, all over a r squared equals to 360. The way I'm looking at these figures here, okay, if I cancel here and cancel here, remove this and this, by indices, r raised power 5 divided by r raised power 2 will give me r raised power 3 because you can subtract their powers. Okay, that's what indices say. You know, we are still coming back to indices and we are going to discuss it a lot. So hang around, please subscribe so that you know when we start doing that. Click the subscription button. Okay, here we go. Let's see how we can reduce this and this. Let me try using 5 divide this, 5 divide 1215 divided by 5, it gave me 243. So 5 goes here, 243, and 5 goes to 360. 360 divided by 5, 72. Okay, let me see, because this is not, cannot be raised to an index, while this can. Let me try something again. I think this can be divided by 9. So 243 divided by 9, 243 divided by 9, 27. Wow. So 9 goes to 243, gave me 27. And let me check, 72 divided by 9, 8. Wow. So this has come down to 8. So I now have r raised power 3 equals to 27 over 8. That's good because these two figures can be raised to an index. So I have r raised power 3 equals to 27 is 3 to power 3 and 8 is 2 to power 3. Both has the same power 3. So I will write it like this. So you can conclude that since their powers are equal, equate the base, then means that the common ratio r is equals to 3 over 2. With this now, we can quickly run down to equation 1 and get what the first term is. So let me do it over here. Okay, so you say from 1, that is equation 1, we have seen that common ratio is 3 over 2. We can substitute it in equation 1 and have first term bracket 3 over 2 raised to power 2 equals to 360, equals to 360. Okay, so what do we have there? A, first term, divide both sides by this. Let me write it again the way you will understand. 9 over 4 equals to 360. So you know when you have 2x equals to 10, what you normally do is divide both sides by 2. So this is 9 over 4a equals to this. So divide both sides by 9 over 4. Okay, so you are going to have comma. When 9 over 4 divide down the 5, 9 over 4, what I'm trying to say here, let me not rush, is if you have 9, if you have 9a over 4 divided by 9 over 4, that it will become an inverse, something like you turn this upside down, it becomes 9a over 4 times 4 over 9, which will now, this cancel this, you have a left. So this will be a. Then on this right hand side, we also have 360 divided by 9 over 4. So that will give us a equals to 360 over 1 times 4 over 9. Of course, 9 cancel this F1, cancel 36 is 4. So we have here 40 left. And 40 times 4. Please proceed it over here. What? I think I have some more questions to answer. Let me not do that. So let me please, in a second, let's see what, because we have not calculated, we're about getting the first term, we have got the common ratio. So as soon as we get the first term now, we can do this C question that say find the sum of the first 4 terms. That's what the last question we are looking at here. Find the sum of the first 4 terms. Find the sum of the first 4 terms. That's the C question. So here we go. I have the first term A equals to 40 times 4. 40 times 4, okay, over 1. And that will give me 40 times 4. 40 times 4 is it 160? Let me check. 40 times 4, 160. 160. So the first term is 160. All right. So they asked us to find the sum of the first 4 terms. So you recall the mathematical expression we use for calculating the sum of a geometric progression. We derived it in the last class. Please go and look at that class. Okay, look at what we did there so that you can be able to follow. That's why I plead with you to subscribe so that you follow whatever we are doing. So in that last class, we were able to derive that Sn is equals to A bracket 1 minus R raised to power n over 1 minus R. This is when R is less than 1. And of course, in this one, the common ratio is it less than 1? This is 3 over 2. And 3 over 2 is 1 point. So it's not, so we are not going to use this one because the common ratio is not less than 1. This is 1.5. It's 1.5. So the one we are going to use is going to be Sn. Here, you can see that our common ratio is not less than 1. I hope you can see that. Our common ratio is 3 over 2, which is 1.5 or 1.5. So the mathematical expression, we could have used this if this is less than 1, this common ratio. Now, for the fact that this is not less than 1, this is not less than 1, we are not going to use this. We are going to use Sn equals to A bracket R raised to power n minus 1 all over R minus 1. That's the one we are going to use for R greater than 1. Okay? So here we go. We've got that A is 160, comma, R is 3 over 2. And then we can make our substitution as S4. That is some of the first 4 terms. I'm sure that this class is not becoming boring. Please, I beg of you, stay with me. All right, equals to 160 bracket 3 over 2 to power 4 minus 1 all over 3 over 2 minus 1. Okay, watch how I'm going to dissolve this. I may not even necessarily need calculator to do it. 160 in bracket 3 raised to power 4 should be 81. 81. Yes. 3 raised to power 3 is 27. 3 raised to power 4 is 81. All over. Then 2 raised to power 4 is 16. Then minus 1. Permit me to write it as 16 over 16 because of this, so that the LCM can become easy and manageable. Divided by down here, divided by down there, we will have 3 over 2. Permit me also to write this minus 1 as minus 2 over 2. 2 over 2 is still 1. It's just to make the mathematical work easy. It's wisdom anyway. So remember that this 160 is covering everything. So here we go. You ask me, okay, why are you doing all this? You know, could have found an easy way, but it's good to knowledge is good. So 160 in bracket. The LCM here is 16. So I will have 81 minus 16. 81 minus 16 equals to 65. So have 65 here. Okay, I'm sure you know how I got that. Divided by this side again, the LCM is 2. 2 divided 2 is 1. 1 times 3 is this. I'm sure you know how to do simplification of fractions. I may give little attention to that, but that would not be now. 3 minus 2. 3 minus 2 is 1. Okay, so we have come down to this. So finally, where am I going to do this now? Let me tidy it up here, please. Let me tidy it up here. Finally, we have Sn equals to 160 bracket. We will now have, can someone see this thing? No, let me bring this thing backward. Please, don't be offended. I'm trying to give you my best, so don't be offended that I'm taking your time. So S4 is equals to 160 bracket 65 over 16, then times 1 over, it will now become 2 over 1. Okay, 2 over 1. So 2 cancel itself, 1 cancel 16. This thing is 16. 8. So finally, I think, let's see whether 8, because this is 160 in bracket now 65 over 8. So 8 divide 160. So 160, I know that is 20. 160 divided by 8. I want to be sure. So that will be 20. 20 times 65. 20 times 65 times 65 equals to 1,300. So the sum of the first 4 terms is equals to 1,300. Okay, so this is how to handle that problem. Okay, are you not going to clap for me? Come on. So please look at it again. Look at it again. Look at it. Look at the simplification as it went. I'm sure it was impactful. Okay, and I'm sure you understood all the steps I followed one after the other. All right, so that you can be able to handle any similar problem that can come along this direction. Thank you so much for being there. Click the subscription button right now as I'm looking at you. All right, and share it to your friends. And also click the notification button so that you'll be notified when we make other uploads. The class will continue. I'm bringing geometric progression to a conclusion. I'm going to introduce a new topic as well. All right, some of my students that requested, I should do, let me not bother you on that, okay? When I introduce the topic, you get to know. Thank you so much. I'm Victor. God bless you.